Afternoon, Johnson's class.
Good afternoon, Mr. Palmer.
Today we did 3.3 equivalent fractions. Can you find equivalent fractions?
Yes.
Fractions have three definitions. The first definition talks about where a fraction lived. Class, where does a fraction live?
Between 0 and 1.
Sure does. Class, the second definition says a fraction is part of what number?
What? 1.
Fractions are part of one whole. I should be up here, Mona. This is making our video longer. iPad should be down. We're doing the video. Our third definition of a fraction is saying that a fraction is nothing more than what kind of problem?
A division problem.
There are two parts to the fraction. There's a top and there's a bottom. What's the top called?
Numerator.
What's the bottom called?
Denominator.
An equivalent fraction would be two fractions that are the exact same, yes?
Yes.
They may not look the same. Does this fraction right here look the same as this fraction right here?
Yes.
Yeah, kind of, but this fraction right here has how many parts?
4.
This fraction has how many parts?
2.
So, is it still the same though?
Yes.
So, would you say that 1 out of the 2 parts shaded is the same as 2 out of the 4 parts shaded on this one?
Yes.
Those are called equivalent fractions, aren't they?
Yes.
When you reduce something, you make an equivalent fraction by dividing the numerator and denominator by a common what?
Factor.
Another word for reduce is?
Simplify.
So to reduce means make smaller. To simplify means make simple. Isn't making smaller making things more simple?
Yes.
They mean the same thing. Good. All right, fractions must always be in what terms?
Lowest
Say again.
term. Lowest term.
How do you reduce fractions? You do what?
You divide.
Divide the top and the bottom?
Yes.
By what?
The common factor.
Is 3/9 a fraction?
Yes.
Can you guys think of a number that goes into both 3 and 9?
3.
Oh my God, there it is. 3 goes into both 3 and 9, right?
Yes.
You could actually figure out a common factor by using, what do we call these things again?
Smiley face.
Smiley face. You don't have to use the smiley faces if you already know. So if you already knew that 3 goes into 3 and 9, you could just write divided by 3. And then divided by 3 because we do the same thing to the top and the bottom, right?
Yes.
So what's 3 divided by 3?
1.
What's 9 divided by 3?
3.
So is 1/3, so is this fraction 1/3 the same as 3/9?
Yes.
They're the same thing?
Yes.
Sweet. Check this one out, 12/18. Notice how we did it twice. See how we did it twice?
Yes.
This way, it actually took us how many times to reduce?
Twice.
This way, we went straight from 12/18 to the answer because we only reduced one time, right?
Yes.
Why did this one, or what do we use here? What number?
6.
6 actually happens to be the greatest common factor for 12 and 18, right?
Yes.
But is it okay to actually do it this way and use a couple of different common factors? Is that okay?
Yes.
It's totally okay. Here's some more examples. Wow, look at this one. How many different ways do we do that one? That's a lot of different ways. Can you find equivalent fractions by doing the opposite of dividing?
Yes.
What's the opposite of dividing?
Multiplying.
So, this is where my last class got stuck. To go from 3/9 to 6/18, to go from 3/9 to 9/27, and to go from 3/9 to 3,000 over 9,000, we multiply by the same number on the top and bottom, right?
Yes.
Is there a specific number that you have to choose to multiply to find an equivalent fraction?
No.
No, it could be,
Any number.
say that again?